Bristol Community College, Mathematics with Dan Avedikian, Math 060, Topics in Developmental Mathematics, Section 2.9, Problem 7. This is Section 2.9, Problem 7. It says 5 2/5 minus 1 3/4. So we have to find the common denominator. So if you have denominators of 5 and 4, a good common denominator would be 20. And now you have to make the numerators match up. So for the upper fraction, the denominator of 5 times some value was equal to 20, so it must have been times 4. 5 times 4 is 20. So the numerator gets multiplied times the same value. 2 times 4 will be 8. And now for the lower fraction, the denominator of 4 times some value multiplies to make it 20. So that some value would be 5. 4 times 5 is 20. So the numerator gets multiplied times the same value. 3 times 5 is 15. So now I have a common denominator, and I want to subtract. But I have to do 8 minus 15. The 8's not big enough. I can't subtract 15 away from 8, so I need to borrow. So the process to borrow is go to the whole number in front of the upper fraction, cross it off, and reduce it by 1. So it is a 5. Cross off the 5, reduce it down to a 4. Then take your numerator, cross that off, and make a new numerator that's equal to the denominator plus the old numerator. So the denominator in this case is 20, plus the old numerator is 8. 20 plus 8 more makes a new numerator of 28. Now I can subtract. 28 minus 15 would be 13. Right? 8 minus 5 is 3, 2 minus 1 is 1, 13, common denominator is 20. Now subtract the whole numbers. So remember, it's not a 5 anymore, I had to borrow, so now it's a 4. 4 minus 1 is 3. So the answer is 3 13/20. Now, you may hate to borrow. Some people do. They don't remember, or they're not sure if they remember. So here's how you can do the problem without borrowing. What you do is use improper fractions. So let's pretend we're going to start from the beginning. So we have 5 2/5, and we're going to subtract 1 3/4. And let's say we started the process of finding the common denominators, and we realized this is the case where I'm going to have to borrow. I'm not sure if I remember how to borrow. So what I'm going to do is rewrite this with improper fractions. 5 times 5 is 25. 25 plus 2 more is 27, and I have a denominator of 5. The 1 3/4, 4 times 1 is 4. 4 plus 3 more is 7, so I have 7/4. And now we just start the problem from scratch. It's the same values, they're just written in a different form. So I have denominators of 5 and 4, so a good common denominator would be 20. They both divide into 20 evenly. So now the upper fraction, the denominator of 5 times some value is 20, so of course it's 4. 5 times 4 is 20. So the numerator also gets multiplied times 4. So 27 times 4, you can go off to one side and multiply it. I can see it's 108. You double the 27 twice. Let's say you don't see that. 27 times 4. 4 times 7 is 28. Put the 8, carry the 2. 4 times 2 is 10. 4 times 2 is 8, plus 2 more that you carried is 10. What I should have said. So 108. So I knew I was going to get a 108. I could see it. Maybe you can, maybe you can't. However you get it, it's 108 over 20. Now do the lower fraction. 7 over 4. You have a common denominator of 20. 4 times some value made it 20. It must have been 4 times 5. The numerator is also times 5. So 7 times 5 is 35. Now I can go ahead and subtract. So 8 minus 5 is 3. Basically 10 minus 3 is 7. 73 over 20. Now 73 over 20 looks different than 3 13/20. So what I'm going to do is convert that 73 over 20 into a mixed number by just dividing. Divide the denominator into the numerator, find the remainder. And it should come out the same. Let's see if it does. So the denominator of 20 divides into the numerator of 73. How many times? Well, Once is 20, twice is 40, 3 is 60, 4 is 80. 80 is too big, so 3 is as close as we're going to get. 3 times 20 is 60. 73 minus 60 is 13. So my remainder is the new numerator, and the number in front of the division is the denominator. 3 and 13 twentieths. 3 and 13 twentieths, same answer. So if you use the improper fractions, it's a little more tedious. You can actually get to the answer faster if you remember how to borrow. So that's probably a little better. But if you don't know how to borrow or you've forgotten by using improper fractions, it'll take slightly longer, but you don't have to remember how to borrow, and you'll still get the same answer.